on arithmetic sequences, if you add or subtract the same thing to each term, it's an arithmetic sequence. With geometric sequences, they're still sequences, but they're not the same. Does anyone think they know what geometric sequences might be? Arithmetic, add or subtract the same thing. Geometric, multiply or divide the same thing. And here I'm going to give you a definition. So here, definition. It is a sequence in which the ratio between any two, and then here's a word, successive terms, is the same. We'll go over that in just a moment. So go ahead and write that down. It is a sequence, and it has a common ratio between any two successive terms of that sequence. We'll see how that works out with some examples. Okay. What is a sequence? Just sequence, arithmetic, geometric. Just what's a sequence? What do you think it is?
A pattern?
Yeah, it's a pattern we're talking about with numbers. Some kind of pattern with these numbers. It can be arithmetic, or today it could be geometric.
May I have your attention, please, for 7th and 8th grade student council members. If you would go immediately to Mrs. Thomas's room during break, she would appreciate it. Thank you.
All right, so any student council in here? Okay, so Ms. Thomas during break. Okay, so sequences are just any patterns with numbers. So we're talking about a specific type. We're talking about geometric. And this is the key. The ratio between any two successive terms is the same. The ratio is the same. And two successive terms just means back-to-back numbers. Back-to-back numbers. Successive, one after the other. All right? Here is another, after you're done writing that down, here's another term that you have to get. It's called a common ratio. Okay, common ratio. That's going to be a big part of your assignment. And that just means a common factor. I'm going to underline that 3 times. What does factor refer to? Factor refers to this operation always. Yep. Multiplication. Now, do you guys remember how at the beginning I asked, what does a geometric sequence, maybe what do you think a geometric sequence is? And we said, instead of adding and subtracting, you're now doing multiplying or dividing. But from previous lessons, I've told you this, and here, let's see if you guys remember. It's been a couple days. That instead of dividing things, I can multiply them by the multiplicative inverse. Do you guys remember that? Do you guys remember reciprocal? Okay, that's going to mean a lot on today's lesson. We'll see how we tie it in together. But we'll start with the easy stuff first. Let's go to example number 1 at the bottom of the page. And we'll start with example 1A. And they give me a set of numbers. 3, 15, 75, 3, 75. All right, today on your homework, you're going to be able to determine, all right, is this a geometric sequence or not? You're going to say yes or no. And then if it is, it says to write or list the next 3 terms. So here I have ... means it keeps going. Okay, am I multiplying by something common on each problem from 3 to 15, 15 to 75, 75 to 375, so on and so forth? Is there something common that's being multiplied each time? Bella?
5.
Okay, 3 times 5 is 15. Okay, so that works. 15 times 5 is?
75.
That works. 75 times 5 is 375. You're like, are you sure about that? You can check it. You can figure it out by just doing 75 times 5 is going to give you 375. Okay, so far so good. Is this a geometric sequence?
That's an arithmetic sequence?
This one?
Yeah.
Okay, it's actually a geometric because what are you doing to get from one term to the next? You're multiplying by the same thing. So this is what I want you to get. You need to give me what the ratio is. What's the common ratio among all these terms? 5. You multiply one term by 5 to get the next term. So the ratio is 5. That's part of my answer. And it's called the common ratio. Why do you think we call it the common ratio, Elizabeth?
Because the ratio is common.
To all of these, right? It's always 5. 5, 5, 5, 5, 5. Okay, it's not different in any one of those. And then I had to list, since it is a geometric sequence, I had to list the next 3. So how do I get the next one? How do I get the one after 375? Okay, so here I want you to start multiplying, and I want you to be very careful. I know you have the answers in your book, but I need you to actually multiply them out. I'm going to check you as you do it. Go ahead. So you're going to do 375 times 5 to get the next term. 375 times 5. Okay, I'm going to watch it as I come around here. If you can multiply 375 times 5, that is going to help you multiply decimal numbers. Well, Mr. A, these aren't decimal numbers, but this is the same process you go through with decimal numbers. All right, I'll go through it myself here. 5 times 5 is 25. 5 times 7 is 35 plus 2, 37. 5 times 3, 15 plus 3, 1875. How many of you got 1875? That is your next, that is your next term in that sequence. Do you know how to find the next two? Yeah, multiply 1875 by 5, and then that product by 5. So you're going to do it 2 more times. Mr. That's a lot of work. Yes, but it gives us good practice. So 1875 times 5 is my next problem. Yes.
Oh, no.
Oh, you got them all? Okay. Okay, I do see different answers. So we'll see which one it's going to be. All right, 5 times 5, 25. 5 times 7 plus 2, 37. 5 times 8 plus 3, 43. And then 5 times 1 plus 4, 9375 is the next one. All right, and then the third one, 9375 times 5. All right, 5 times 5. Do you notice, can you see something which is kind of interesting here? If you work this problem out, like say this was your homework, you did 5 times 5 how many times? 3 times. Do you think you know it better after that? Like even if you already knew it, do you think 5 times 5, 25, automatically. You also did 5 times 7 how many times? 3 times 5 times 7? 35. Do you see as you keep doing these problems, you get a little bit quicker because you're like, oh, I've done that 3 times in the last minute. And you can get them down a little bit better. 5 times 7 plus 2. 5 times 3 plus 3. And 5 times 9 plus 1. 46,875. So those are the next 3 terms in that sequence. Okay? You guys get that? Not too bad. I think this one's going to be hopefully the ones you nail. You're just going to get them. You know them. Any questions on geometric sequence? All right. This is the common ratio. You can figure it out by looking at what they give you. And then, if it has a common ratio, you can figure out the next 3. Fair? Yes.
Okay, so say we have a number pattern and the first number was multiplied by 3 and then 2 and then 3 and then 2. Would that be considered a geometric sequence?
No, because there's no common ratio. If it was just 3 or just 2, yes. But if it's both alternating, not geometric. It's another type of sequence that we'll look at in future years. All right, let's look at B now.
Wait, so if it's not geometric, can we just say no?
You say no, you're done. You're done with that problem. That's nice, isn't it? If it's not geometric. All right, -4, -2, -2/3, -1/6. Okay. I'm looking for a common factor. So does anyone know how I go from -4 to -2? There are two ways you can get there, but I'm looking for the common factor. Can anyone give me what the common factor is? Okay, some of you kind of know. Can anyone give me what maybe I divide by? That's not a common factor, but can you give me what I divide by? How to go from -4 to -2? Okay, watch what I'm going to write here. I'm going to put divided by 2. Okay, that's correct. What is dividing by 2 as a multiplication problem? Remember, stay, change, flip. Wow. Stay, change, flip. Almost got that wrong. Stay, change, flip. So, ready? -4 times, instead of dividing by 2, you can say it's multiplying by half. Do you guys agree with that? Is -4 times a half -2? I don't believe it. All right, so here's the problem. We say it's true, but I don't know. What's -4? Well, can you do this? What do you get?
-2.
Good, -2 over 1 or -2. So you guys see it? Okay, fair enough. What did I do to go from -2 to -2/3? And this is where if you can see what fractions can also be known as, you can see it right now. It's tough. We're trying to train your eyes here to see. I may not know what I multiplied by, but I do know what I divided by. Ready? Okay, -2 turns into -2/3. Isn't this -2 divided by 3? So what did I divide by? 3. I divided by 3.
So it's times 1/3?
It's times a third. Times a third. Okay, how about this? If you don't believe it, it's okay. This is what I'm going to have you do. Can somebody work out what's -2 divided by 3? Can someone work that out? -2 divided by 3. And leave it. You can leave it as a fraction. You don't have to divide it all the way through. It's going to be a repeating decimal. Okay, ready? You know what this is also known as? -2/3. Aren't these the same thing? Okay. But Mr. A, you also said that -2 times 1/3 is -2/3. That I can't live with. All right, stay, change, flip. Stay, change. What's the flip of 3?
1/3.
1/3. What's that going to give me? Yeah, specifically, -2/3. Okay, you should be able to say this is being divided by this, and also be able to change it to what it's being multiplied by, because it is being multiplied. All right, this one's the hardest one. Does anyone know what you did to go from, I'm going to leave that there, from -2/3 to -1/6? Maybe you can kind of see a pattern, kind of see it there. It's there. I'll help you out. Jensen? Let's see here, divided by 4. That doesn't look like it.
Yes.
But if it's division by 4, what is it being multiplied by? What's the pattern here? 1/2, 1/3? It could be considered multiplied by 1/4. Is that really true, though? All right, what's -2/3 times 1/4? You guys see where I'm getting that? -2/3 times 1/4. Does it really give me -1/6? I don't know. Here, what do I get?
1/6.
-1/6. So is that true?
Yes.
Okay. I am not too concerned about the division by 2, division by 3, division by 4. Like, if you could pick that out, that's hard. I am concerned with this part. Can you identify this? Like, if I said division by 2, can you say multiply by 1/2? Can you identify this? Division by 3 is also multiplication by 1/3. Can you also identify this? Division by 4 is multiplication by 1/4. If you can figure that out on this example, you're good. But I have an ultimate question to ask. Is this geometric? Bella?
No.
What? There's a pattern. There's a pattern. Can't you see it?
But it's not the same number.
Do I have a common ratio? Am I multiplying by a common thing? No. You don't have to find the next three. There's no common ratio. You're done. Yes?
Can you stop at the second one?
Yep, because you said division by 2, division by 3, or multiply by half, multiply by a third. Done. Yep, I just want you to see this relationship here. This and this. All right, ready, guys? I'm going to test you out since you said, yeah, we get it, Mr. A. I get it. I get it. And maybe you did it blank face, but let's see. Division, and don't say it out loud, I'll call on someone. Division by 5 is also, Sydney?
Multiplication by 1/5.
How many of you would have gotten that? Division by 5 is multiplication by a fifth. Oh, good. What about division by 10? Give it to me, multiplication. Jack? Times 1/10. Huh, interesting. Right? Ready for it to get a little bit tougher? Okay. Division, don't say the answer, by 2/5. Division by 2/5. What in the world would that be multiplication-wise? Timothy?
Times 5/2.
5/2.
Reciprocal? Yes.
Okay, how many of you would agree that these two numbers are reciprocals?
Yes.
How many of you would also agree that these two are reciprocals?
Yes, because 10/1
We're just talking about reciprocals, right? It's there. It's there. The pattern's there. Can I give you a tougher one?
No.
Yeah. How about this? I will give you a tougher one.
I am because it's originally 10/1. Ooh, I got this.
All right. When I count to 3, give me the answer. Okay? So I'll say 1, 2, and then the number. Then you give me your answer. Ready? 1, 2, 3. Oh, times. I think you guys gave me what I wrote. -3/5. Okay? These two are the same. These two problems are the same. I want you guys, though, I don't want you to accept what I say just because I said it. Because sometimes I'm wrong. Well, wait. Swivl, did you hear that?
Wrong.
At 17:45, Mr. A said he was wrong. Okay. I am. Sometimes I'm wrong. I want us to be able to figure out for our own to say, yes, this is a correct statement, not because some teacher said it, but because it's true. I want you to give me a fraction, Josie. Fraction. 2/5. All right. I want Elizabeth to give me a second fraction, not with a 2 or a 5. How about that?
7/13.
Thank you. Thank you. Thank you. Thank you. All right. All I want you, I don't want you to work this out. I just want you to rewrite it as the inverse operation. Can you do this? Rewrite as a division problem.
Yes.
Rewrite as a division problem. Okay, I have 1, 2, 3, 4, 5, 6. So I just rewrite it. You don't have to work it out. I'm just rewriting this problem. Okay, I'm going to call on someone now. Braden, rewrite it as a division problem.
5/2 divided by 13/7.
Close.
No.
You keep the first one the same. Max?
2/5 divided by 13/7.
Are these two the same? Okay, I'm going to do something to you guys. I hope you're ready for it. Okay? Stay with me.
Where do you go to bed?
Stay with me. You're going to have to wait a little. It's a fraction. No problem? Another fraction bar. And another fraction. I want somebody to give me the division problem that is shown right here. It's a division problem. Oh my, I know, that's shocking. Sophie, what's your division problem?
2/5 divided by 1/3.
2/5 divided by 1/3. That is correct. What's the multiplication problem shown here? You can see it from both Callie?
2/5 times 3/1.
2/5 times 3 over 1, or just 3? That's correct. Can you guys see it?
Yes.
This, okay, what I threw out to you, I threw something out. I think they're ready. And then some of you guys, some of you didn't. From here to here, that's algebra 2. That's algebra 2 stuff right there. Okay? You're like, I can do that. Great. You'll be ready. Okay, let's go back to geometric sequences and letter C. Yeah, this is, I like this. The whole point is I want you to tell me if it's divided by something, how do you rewrite that to be multiplied by something related? Because I want multiplication, I don't want division. -4, 1, -1/4, and 1/16. Dot, dot, dot. Okay. Before I work this one out, do you guys notice that it's alternating from negative to positive, negative to positive? Or do you guys see that? Negative, positive, negative, positive. What do you think the next sign is going to be? Negative, then positive. Okay. If it alternates in that way, if it's going from negative to positive, ignore the numbers. I know that if I have a common ratio, I'm not saying we do necessarily, if I have a common ratio, it's got to be negative. It's got to be negative. Whatever it is, it's got to be negative something. Because how do you change a negative into a positive? You multiply by a negative. How do I make a positive turn into a negative? You multiply by a negative. Negative, negative. All right. So I'm looking at this and thinking, maybe I can look at it division-wise. So what did I do to go from -4 to 1? Division. So you can think division, but we're going to convert it soon. So division, what did I do? Sydney?
Divided by -4.
Okay, good. How many of you say divided by -4? Okay, I agree with that. All right. So do you see how to go from 1 to -1/4? Divide by -4. Okay, and then from -1/4 to 1/16?
Divide by -4.
If you can see that, you can give me the common ratio. Hint, hint. The common ratio is not division by -4. It is multiplied by
1/4.
-1/4. It's multiplying by -1/4. That's a common ratio. Do you guys see that? Okay, how many of you saw this division by -4? Right here, and then even here. Okay, do you remember division by -4 is actually multiplication by, what's the reciprocal of -4?
4 1.
-1/4, yeah.
1/4.
1/4, -1/4. So that's how I got that common ratio. Is it a geometric sequence?
Yes.
Yes. So how do I find the next terms? Well, I could divide by a -4. That's going to make it harder. What do I do to 1/16 to get my next number? What do you think I should multiply by? Josie? -1/4. I'm going to multiply 1/16 by -1/4. What is that? Negative. What's 1 times 1?
1.
So far, so good. What's 16 times 4? 64. And if you didn't know how to do that, you can work it off to the side and get 64. That's the next term. How do I get the term after that? How do I do that? Yeah, so what do I write? Sophie?
Times -1/4 equals 256.
Give me a specific answer. I want the specific correct answer.
-1/256.
Close. It's 1 over, yes, what's a negative times a negative? Sorry, positive. And then you get your 256, right? Negative, or excuse me, positive 1 over 256. Yes, ma'am?
So when we're doing these and you're dividing, and if you can figure out the whole number, is it always going to be a reciprocal?
Yeah, that common ratio is going to be the reciprocal, and that's what you would multiply each term to get the next. All right, how do I get that final one? Well, what was my second term that I need to get? 1 over 256. So what do I multiply by? Yes, ma'am?
-1/4.
-1/4. Is that positive or negative answer? Negative. What's 1 times 1?
1.
And then the hard part was what's 256 times 4?
1,024.
1,020.
1,024.
It's
1,204.
1,024.
Yeah, good. 1,024. Sorry, I had a mental block, and I was like, what's going on? Negative 1 over 1,024. So what are the next three terms?
164.
Negative 1/64, 1 over 256, and negative 1 over 1,024. You guys get that? That's a hard one. It's a hard one. Yes, ma'am.
So if we made the common ratio to be negative 1/4, then why didn't we, when we were on example 1A, why didn't we change the 5 to 1?
Good question. So this common ratio, so listen up. How do I get this number right here? I thought it was negative 4 or is it negative 1/4? Which one is it? It's what did you multiply this to get to that? So I divided by negative 4, but I want to know what I multiplied by. So I multiplied by negative 1/4. On the last problem, what did I multiply? Each one to get, I multiplied by 5. So that's what I multiplied by that number to get the next.
Is that all we're doing for this one?
Yeah, so I want to see if you guys can get on your own. I'm going to give you 2 problems, and hopefully you can get it. On page 315, just do number 6. See if you can do number 6. State whether each sequence is geometric. So you just write yes or no. If so, state the common ratio. So that's this right here. This is the common ratio. And if it is, write the next 3 terms. If it's not, you're done with the common ratio and the next 3 terms. You don't have to do it. I'll come around with questions. So again, a common ratio is what I multiply to get to the next term. 6 on page 315.
Would you just put common ratios?
Because you multiply by 3?
Would you make us put that as the common ratio?
No, so the reason I sometimes change it from 3 to 1/3 is when we figure out what you divide by. Like I can know what I divide by, but the common ratio is going to be the reciprocal. Did I find what I divide by? Nope, I find out what I multiply by. So just leave it like that. All right. Geometric or no?
Yes.
Okay, everyone should have geometric, which means it has a common ratio, which you found to be.
3.
All right, do you guys see that you multiply the first term by 3 and you get the second term? Second term by 3, you get the third term, and so on and so forth. 3 is a common ratio. What are the next 3 terms? One at a time. I'll ask you for one of them, then you'll give me the next. All right, number 6. Sophie.
First one's 81.
81 is the next term. Second one, Elizabeth.
243.
243 is the second term, and the last term, Max. 729. 729. All right. How many of you got all those? Okay, good. This is a tough one I'm giving you to see if you can get it, because it does get a little bit tough. Number 9. Number 9. Mister, it's not too bad. We'll see. Just work it through carefully. If you figure it out by dividing, just make sure to change it to multiplication. So you can figure it out by dividing, but you have to change it to a multiplication problem.
Wait, did we see whether it's
Geometric or not? Yep. Say yes or no. If yes, I need the common ratio and the next 3 terms. How many of you can kind of figure out that you're dividing by 3? Like you're like, oh yeah, you're dividing by 3. Divide by 3, divide by 3, divide by 3. You guys get that? Okay. What's the common ratio then? Be careful. Good. It is 1/3. because you multiply by 1/3. You don't multiply by 3. Okay, that's the common ratio. So now I need the next 3 terms, and this is where it can get a little bit tough. So how'd you get the next term after 3? What would you do for the next term after 3?
Just divide by 3, but
Okay, so what'd you guys do, Jensen?
I divided and then I multiplied on some.
All right, so how many of you would do 3 divided by 3 and you got 1 as your next term? Okay, that's fine. You could do it that way. Did anyone multiply by 1/3? Did anyone do 3 times 1/3 and you still got 1? You still should get 1. Now I'm going to do 1 and you have a choice. You can multiply by 1/3 or divide by 3. Your choice. And either one's going to work as long as you're careful. So who did it? Dividing by 3. Okay, so you could divide by 3 and you should get 1/3. Isn't 1 divided by 3 1/3?
Yes.
Okay, or you could have multiplied, so I'm going to put this off to the side, 1 times 1/3, which also gives you 1/3. All right, the last one, the easiest way to do it is to do what? What would you do to get that last term? Yes?
1/3.
Multiply by 1/3. And what's 1/3 times 1/3? 1/9. Your terms are 1, 1/3, 1/9. You guys get that? That was tough. Hopefully some of you got it. If not, that's okay. You keep practicing, you'll get better. Your homework tonight, or tomorrow night, or Sunday night, or Monday morning, hopefully not, is 15 to 29 odd. 15 to 29 odd. And then 39 to 41. So just a few more problems.
what did this do?
Monday. Unless there's a snow day. Bad on.
Oh.
Actually, kind of hope you're not.
Good.